Hi everyone, welcome back to Codemaster Java. Today we are tackling a classic Leetcode problem, product of array except self. So imagine you have an array and you need to calculate the product of all elements except the one at the current index without using the division. Sounds tricky, right? But don't worry, we will break it down together and show you an efficient way to solve it. Without further ado, let's get started. So here is the problem. Product of array except self. It is a medium level problem. And here is the problem statement. Given an integer array nums, return an array answer such that answer of y is equal to a product of all elements of nums except nums of y. Okay. And we need to write an algorithm that runs on big of n complexity and without using the division operation. Okay, so that is tricky. This problem is very easy to solve using a big of n square complexity using a two for loop. But as mentioned in the uh, problem statement itself, like we need to run this in the big of n complexity. But before going to the solution approach, let's look at an example that we were given. So the input array is 1, 2, 3, 4, and we need to return 24, 12, and 86 because 2 multiplied by 3 multiplied by 4 is 24. Okay. For 12, it's 3 multiplied by 4 multiplied by 1, and for 8, it's 4 multiplied by 2, and for 4, it's 3 multiplied by 2 multiplied by 1. Okay, that's uh, that, uh, that is obvious, right? So let's start with the common approach, like with the time computer because n square. So for that, what we will do, like we have to create an two integer array, two for loop with the length of the array, so length of the array, the one variable, and so that we will start the for loop with the starting position is 0. So for okay, now for this we will check if the indexes of the both for loop is same, we'll not use that element because we need the product except the ith index. Okay, and to store the temporary product, let's create temp value as one, and the temp is equal to num for j. Okay, that will give us the answer, and for the answer one array, create an answer array, which is this as well. Equal to 24 loop array. This will solve the problem, but the time complexity for this approach is big of n square. So that is not we are not this is not expecting in the problem statement. So we need to optimize it. So how can we optimize this? So let's discuss about the solution approach. Let me remove this all. So what we can do, we can to get the product of, for example, let's get the product of 3. How can we do that? It's 2 multiplied by 1 and it's in the 4 here. So it's 8 because 2 multiplied by 1 is 2 and the 4 multiplied by nothing. So 4 multiplied by 2 is 8. That's how we are getting the product of each index without set. So for that, we can use this approach, like we will create two new arrays, left and right. So left array will store this product from the left side, and the right array will store the product from the right side. For example, 1, 2, 4. This is the given array. So for the left array, we will store like 1, 2 multiplied by because there is nothing. from the right side of the first index. So it will be 1 itself. For the 2, it's 1. For the 3, it's 2. And for the 4 element, it's a 3 multiplied by 2 is 6. Okay. So now for the right array, we will start from the back and 1, 2, 3, 4. Okay. So for the right index, so there is nothing right from the fourth element, right? So it is 1 obvious. For the 3, it's a 4. Okay. 4. For 2, it's 12. And for the 1, it's 2, 3, 4. It's 24. Okay. So what will be our answer? Answer will be left of I multiplied by right of I. So it's 1 into 4. So it's a 24, 12, 8, and 6. So that is our answer. C. Magic, right? So we can use this approach to solve this problem. So let's create two array. Left is equal to new and integer array. Right is equal to new integer array of n. Now we have to set left of 0 is equal to 1 because there is nothing, uh, there is no element from the left side of the first index. Same with the right side because there is no element from the right side of the last element. We will store the both elements of both element as of 1. Now what we will do, we will create a new for loop which will start from the first index because we are looping through for the left array. So, and we already know the answer for the zeroth index. There is no need to calculate it. It will go to the length of an array. Okay, and we will store left of I as. So if we check this ith element here, so we are right now we are here with this first index. So for this, the left product is like 1 multiplied by 1 equal to 1. That's why it's here 1. For the 2, it's a 2 multiplied by 1 is equal to 2. For 6, it's 3 multiplied by 2. That's why it's a 6. Okay. So obviously like we have to I minus 1 multiplied by nums of I minus 1. Okay. So I minus 1 because we do not want to calculate number itself. That's why I minus 1. For the same, for the right array itself, we already know the answer for the n minus 1. So it will start from n minus 2 and it will be greater than or equal to 0 and I n. Okay. So we are using the reducing loop. Okay. For the right of I is equal to, so we know the answer for the I plus 1. Okay. We will use like here. So because 1 multiplied by 4, it's 4. Okay, for the this index, it's 4 multiplied by 3, that's why it's 12. 12 multiplied by 2, that's why it's 4, 14. Okay, for that, I plus 1 multiplied by nums of I plus 1. Okay, so we have created two array left and right, and now we have populated the value of the left product and right product in uh, respective arrays. So now we will create a new loop. We'll start from 0 to length of the array, and that we will fill the answer array with the left of I, left array of I multiplied by right array of I. Okay, so that we will return the answer. That's it. We got our left product by using the prefix product and the suffix product. Let's check it out if it's working or not. Yeah, it's accepted. Let's check the time complexity of this one, how much time it is taking. So see, it's taking only 2 milliseconds to complete. Okay. And the time complexity and the space complexity of this one is the big of n, because we are using the two new array to store the values. That's why it's big of n. And the time complexity is also big of n, because we are using only one for loop, three for loop, but it's a linear. That's why 3n. That's and based on this, it's a big of n. So that's it. Uh, this is the optimized solution for this one. Again, in the follow-up question, they have given like, can we solve this problem on big of one space complexity? Yeah, that is also possible. So to do that, we need to remove all this code. Okay. Now we have to think like how can we solve this problem without using any new array? Okay. So right now we don't have any new array, and how can we solve this array? So it's simple. Uh, we will use the answer array itself. So the current before before doing anything, this is these two arrays we got. After that, what we will do, we will store the left product of each element of the num in the answer array. After that, we will compute the right product and we will multiply by with the existing answer array, and we will get our answer without using any extra space. So let's see how can we implement this. Okay, so in here, uh, to get the left product, it's very easy, right? We already know the zeros index is a 1, so we will store that, and answer of I equal to answer of I minus 1 multiplied by nums of I 1. That's how we will get our answer array with the left product. So it will be 1, after that 1, after that 2, then 6. 1, 1, 2, 6 we will get by using this only condition. Okay, so let's quickly do that. So 1, 5, 1, 5, 1. So now our answer array is like this. Comes 4. Now how can we multiply by the right product? Okay, so as usual, we will start from the back, um, and we will use new temporary variable to store the right product. So they because we cannot use the array, no? So we will use the variable to store the current right product. We, as for the last element, there is no nothing in the right. So the right product of this one will be 1 itself. Okay, so that's why we are storing it 1. And so the right of I is equal to the new variable which we have created multiplied by nums of sorry answer of I. Okay, so that will give us the product of the right of this. Now we have to store a new right for this. So how can we do that? It's like temp equal to temp multiply by. So it's here 6. Okay, so we got the 6. Now let's for the 3. Let's look at for the 3. It's a 4, right? 4 multiply by 6. Oh, sorry. For the third index, it's a 2 multiplied by 4. Okay. So what we have to do is we need to compute the current index. Okay. Current index of the answer, and we need to compute the temporary variable, which is what is that is the current temporary variable. Okay. So for that we need to do answer of I. Okay. So by using this, you can sort this out like. So what it will do for the last index, for example, for the third index, we are setting as a current. Let's do the loop. Okay. The loop first loop temp equal to 1. Okay. Second temp will be for the second loop. We are currently here. It's 4. Right now the temp is equal to 1 multiplied by 4. Temp is here 4. Okay. So after that we will calculate this to this. Based on this, we will get our temp. Okay. So we need to use this. So let's do that as well. For equal to n on the x one and the last index n equal to okay. Right of equal to number itself 1 multiplied by answer of I. Okay. Now let's store the temporary variable itself. Not answer of I, it's the nums of I. Okay. Because we are getting false from the nums error, right? That was my mistake earlier. Now we got our answer, right? So let's take it out. We'll have our answer. It's working. Oh, sorry. Sorry. Answer of 5. Accepted. Let's submit it. Okay. It's taking 2 milliseconds, but the current time, sorry, space complexity is big of 1. So we have again optimized the space complexity for this video for this problem. Okay. So in this optimized version, we use the answer array to store the left product initially and then update it with the right products. So this approach reduces the space complexity to big of n beyond the output array. So that's it for today's problem. I hope you found this explanation helpful. If you did, make sure to like, subscribe, and hit the bell icon so you don't miss any of our future updates on the videos. And as always, feel free to drop any question or comments below. Thanks for watching. Happy coding. See you. Bye bye.